Average value of a function. What we're going to do is we are going to actually add up all values, and then we're going to divide it by the number of values. Isn't that what an average is?
Yeah, it is.
All right, so here we have this lovely little rectangular box that has an area A. And if we wanted to look at the area, it's this distance B minus this distance A times my height. Does that make sense? Now what happens if it's curvy? It's still going to be the area under the curve from A to B of whatever my g of x is. Okay? So now what I've got here is I'm going to say b minus a times my height is the integral, so I set this equal, and then I solve for my, and v does not stand for volume. In this case, this is what they're using for value, average. All right? So here's your formula for an average value. You're going to take 1 over b minus a and the area under the curve. Now notice it has to be continuous, and b has to be bigger than a. You can't go the other way. All right? And this is the formula, and they do have several, and I know that I'm going to have a AP problem for you guys that has to do with average value. We're going to work again Thursday at guided study. F of x equals x squared minus 10 on this closed interval. So I'm wanting to find the average value. And this is A, this is B. So we're looking at 1 over 2 minus a minus 1, going from minus 1 to 2. And there's my function. It's finding the average value on the function. So if you had a bunch of data, maybe it had to do with velocities and you wanted to find the average velocity. So here we have 1 over 3, negative 1 to 2, x squared minus 10x. Is the integration difficult?
Nope.
Nope. So now you have x cubed over 3 minus 10x going from negative 1 to 2. And you should end up with the lovely number of negative 9. So I got 8 cubed, 8 over 3 minus 20 minus negative 1/3 plus 10. And you end up with negative 9. Okay? It's the average value of this function.
How long is this lesson?
I don't know. Is the battery going down?
Nope.
Nope. All right, so approx to 2 decimal places, the average value of this function on this interval. Again, average value. If you write down at least parts of the formula, you should remember them. At least that's how I remember things. If you keep writing it down, it eventually becomes a habit. I certainly can. So now I've got 1/3, and I'm going to integrate this. How do you integrate that? Let's bring the 4 out. What's the integration of e to the 2x?
1/2 e to the 2x.
1/2 e to the 2x going from 0 to 3. So what I could do is I could say 2/3, and it's e to the 6th minus e to the 0. Be careful of e to the 0.
Equals 1.
There you go. So e to the 6th minus 1. Put this in your calculator and you get that number. There's your average value to 2 decimal places. The AP test usually requires how many? 3. All right. Now we're going to use this with the mean value theorem. So flip it over.
Flip. Lots more to do.
All right, here's the mean value theorem. You've got, in the mean value theorem, you've got A to B. And basically it says, in the mean value theorem that we had before, if you connect the line to those 2 points, then there's some C in between here that has the same slope as this line. Maybe it's here. Maybe it's up here. That's the mean value theorem. Now we're going to use it with average values. So if f is continuous on the closed interval, there exists at least one number c between a and b where f of c equals this. Now remember, the mean value theorem had f of c equals f of b minus f of a over b minus a. This is the slope, and this is the derivative. Okay? So here we have, given this average value on the function is that. Use the mean value theorem to find a number c so we can find out what c gives us that value. So right away we have 27 over 2 equals, so we're talking 2c cubed. Can I find out what c equals?
Yep.
So now what I have is 27 over 2 equals 2c cubed. 27 equals c cubed. C equals 3.
Wait a second.
Did I do it right? Divided by 4. Nope, I didn't.
Yep.
It's okay. I'll make mistakes.
Yes, we do. 27 over 4. How do I find c? It's 3 over the cube root of 4. That's c. Leave it like that,
Nice.
or you can approximate it, but if you're ending up putting it into something else, you can leave
I
it
don't
like
think
that.
people at home can tell what that says. That's okay.
All right. Can I write it over here? 27 over 4 equals c cubed.
There we go.
Why are we filming? Jay, you put the iPad in the thing, it'll be a screen of a screen. Yeah, it's pretty trippy. It's trippy. Oh my goodness.
Oh, I
It's
don't
a
know if you can see
reflection.
it.
Whoa. Of the
All right.
That's cool. A screen of a screen.
Here's the key, guys. The mean value theorem can't be used to find anything.
Sorry, guys.
Can't
Talking to
be
people at home.
used to find anything.
Amen. People at home trying to
It is just an existence. It tells you it exists. So we used algebra to find it. Of course, your teacher did a poor job of the algebra, but it's in here.
It's okay.
Okay? It states that C exists. Okay? We used algebra.
It's a nice ring.
Thank you. My husband got it for me. I'm not going to do the proof. See the book if you want to see the proof.
Yes.
Okay?
See book.
It basically tells you that the mean value or the average value is between the minimum and the maximum. And you go, really? Think about it. Does that make sense? The average value is going to be somewhere between the min and max. You're like going, yep. That's obvious. All right, so now suppose we could do it.
I want to.
All right, let's do it.
It's right there.
Didn't we do this one already?
Yes. I don't think so. I don't
It's
think so.
page 285 in your book. Okay? Larson.
Yeah,
In Larson. All right, at different altitudes in Earth's atmosphere, sound travels at different speeds. Do you guys remember hearing that? And the speed of sound in meters can be written, and here's, basically they have a line for this one, they have an equation for this one, they have an equation for this one. These are all piecewise functions. All right? And it says, what is the average value of the speed of sound over that interval? So you're going to actually begin with, over the interval, from 0 to 80. Okay? Now, how many piecewise functions do we have?
Was that a 5 class of exercise?
That's an S. That's why I do cursive, Josh.
Yeah.
This time I didn't. So you have to take it in piecewise. You have to go from 0 to 11.5. Find that one. And you have to go from 11.5 to 22, and 22 to 32, and 32 to 50, and 50 to 80. Okay? And you're going to take the first function. None of the derivatives are difficult. Now you could actually put this in your calculator and get the derivative, right? Have you done that in your calculator yet, where you find the integral, I mean?
Yes.
Now this is going to be tough getting it on this screen. So if you put in, I'm just going to put math up to integral. you have to put negative 4x plus 341, comma. You're taking the integral with respect to x, comma, and you want to go from 0, comma, 11.5. And you should get a value.
Hey, where is it at?
Math, and it's a function.
Value.
So we got 3, 6, 5, 7. If this is a typical problem on an AP, you use your calculator. So you're going to take this, 295, and if I plug this into my calculator, I'm going to get 3097. Now, do you guys need me to plug each one in? You know how to do them?
Yep. Yes.
All right, so now I've got 3/4 x plus 278.5, and you get that in the function integral as well, and you should get 2987.5. Plug this one in. Now, if you're struggling on how to put it in your calculator, come see me. And this last one, okay? So if I want to know what it is from 0 to 80, what do you think I should do? Add them all up and you get 24640. So you're going to add all of these up. Now what do you think the average speed is? So you're going to take 1 over 80 minus 0. And the integral from 0 to 80. Well, we already know what that is. It's 1 over 80